Hi and welcome to today's video where I'm going to show you a little bit about how to go about answering Lewis diagram and shape questions in your exam. So what I've got here is the 2017 Structure and Bonding exam question. And in this question, there's a question about iodine forming the linear I3 minus ion, drawing the Lewis diagram for it and then explaining why it has a linear shape. Now, to explain shape, you have to have a Lewis diagram to start with. So some questions will give you a Lewis diagram. It's actually unusual for them to fall in this format where they actually ask you to draw the Lewis diagram first, because if you screw up the Lewis diagram, then your shape explanation will be screwed up as well. And then they have to do follow-on marking. So if you've done a incorrect Lewis diagram, but your explanation is correct for your Lewis diagram, then really they should be marking that Lewis diagram correct. Anyway, let's have a look at what we've got here and what we might be able to put in. So starting with the Lewis diagram, we've got an I3 minus ion. So we need to figure out, first step, how many valence electrons there are available in our molecule. We have 3 iodines with 7 valence electrons in each, so that would be 21. And then we have an extra negative charge, so that's going to give us 22 valence electrons in total. Next step would be to draw out our valence electrons. So we've got an iodine, followed by a second iodine, followed by a third iodine. Okay, we're going to put bonds between our iodine atoms. Okay, so 2 bonds. It's going to use up 4 of our 22 electrons. We've still got 18 electrons left to put onto our molecule. So we're going to put them around our outer atoms first, and then any extras around the central one. So we've got 18 electrons to go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we're going to have to put the last 6 in the central atom. 13, 14, 15, 16, 17, 18. Because it is an ion, we need to put it in square brackets with the negative charge. So there's our Lewis diagram. That's our achieved point. Explanation. Explain why it has a linear shape. Well, I'm going to start off. The I3 minus ion has 5 regions of negative charge surrounding the central iodine atom. Count them if you need to. We've got 1 in the bond, 2 in the bond, and then 3 lone pairs. So it's got 5 regions of negative charge around that central iodine atom. These regions repel each other for maximum separation, forming a trigonal bipyramid shape. There are 2 bonding and 3 lone pairs of electrons. The lone pairs of electrons will take the equatorial positions, leaving the bonded pairs in the axial positions, giving them a bond angle of 180 degrees in a linear shape. That's what we're looking for an answer. Okay? So it's all coming back to that. Let's talk about what's happening in terms of how many pairs of electrons there are around our central atom. They're repelling each other, they're giving a shape. Where are the lone pairs? Where are the bonding pairs? What is the overall shape made by the bonds in that molecule? Okay, let's see if we can have a look at another example. Okay, it is fairly common for shape and polarity questions to be rolled in together. And my next series of videos are going to be talking about polarity. Right now, I just want to talk about the shape. So this particular question, which was from 2018, was talking about xenon tetrafluoride. In this case, the shape was actually explained, and as you can see, the Lewis diagram is given to you. but the question is to elaborate on both the shape and polarity. Now, I'll come back to the polarity a bit later, but just expanding on the shape, you've already been given the shape, but the question is to explain why. When you see elaborate written in an exam question, what it's actually asking you to do is tell me everything you know about this stuff. Okay, so if we're talking about xenon tetrafluoride, we're going to start off with the same sorts of things. So the xenon XeF4 molecule has 6 regions of negative charge surrounding its central atom. These repel for maximum separation to form an octahedral shape. There are 4 bonding and 2 lone pairs of electrons, meaning that the lone pairs of electrons will take up the axial positions in order to get as far away from each other as possible, leaving the shape of XeF4 to be square planar. You would then continue on talking about the polarity and explaining why, in this case, XeF4 is non-polar. But that is a discussion for another video. Thanks for your time, and we'll have another look in the next video where we start talking about polarity. See you then.